So we're going to continue. Welcome Victoria and Sebastian about finally fixing multi-GPU on Linux.
Hi. Yeah, this is not like we've done this. This is more of like a proposal. We should really do this. Hi. So yeah, we'll be talking about multi-GPU on Linux. Everybody who has encountered it probably knows it's a pain. First, a couple of words about who we are. I'm Victoria. I work at System 76 on the Cosmic Desktop environment and mostly do Wayland Compositor stuff there. I'm also a member of Wayland protocols, so you usually see me online doing like cursed Wayland stuff, and also active in various free desktop spaces. Yeah, hi.
Test. Okay. Hi, I'm Sebastian Wick. I work at Red Hat. I work mostly on Mutter and Flatpak nowadays, and I also work a lot of on other free support things. Yeah.
Okay, so the issue we want to talk about, multi-GPU has a really bad reputation on Linux. Usually people assume it's slow, so why would you use it? The whole point of having a dedicated GPU is that it's faster, right? It's a big power draw and there's nothing you can do about that. It's also super annoying to get working, there's tons of forums full of environment variables that people share that nobody actually knows on the user side what they're doing. People kind of want to manually select the GPU and then expect that they need to log out or even reboot to change that because this is how it's been on X.Org and for ages. And of course the situation has not improved, right? Of course, a lot of magic prime utilities also exist, some super obsolete, most not really working anymore, but people still use them because they're used to it. And the actual benefit of these applications is questionable at best in a lot of cases. We want to argue that none of this has to be true. Even if there's a bunch of code paths that are slow and could be optimized in the drivers, we can already do so much better in user space than we currently are doing. Okay, so a rough outline for the talk. We will go into each of the actual technical problems we feel are there and need to be solved. Then we talk a little bit about prior attempts to solving this, what currently exists, and how well that is addressing these concerns and ongoing efforts. And then in the end, we present the thing that we want to contribute to this to finally remedy this whole situation, hopefully. All right, problems. First one is client-side GPU selection. In general, I think this is a very good idea, but with Vulkan and nowadays even with EGL via EGL-X explicit device selection has completely moved into the client, which is usually very clueless about what it actually wants. For example, if you as a user are running your laptop on battery and you want to make sure that the dedicated GPU stays off, you have no control over what the client application does, or every client application does something different, has its own configuration and might just power on the GPU, and you have no influence over this because all of the GPU selection now lives in the client. I don't think that's a good idea. I think at some point, something in the system should be able to say, no, please just don't use this GPU, or this would be the preferred one, or whatever, and then the client might have good reasons to override this, right? But not leave the whole logic to them, and every client and every toolkit has to re-implement the world to solve this problem. At the time of writing this talk, Fractal was happily using my NVIDIA GPU. I assume because of the new GTK Vulkan renderer. I have no idea. I have no idea what business it had in doing that. So this is the kind of problem that I think shouldn't exist in the first place here. Next one is containers.
Right. So nowadays, a lot of our applications are running on containers. If it's I don't know, some compute stuff in Docker or Podman, or on even desktop machines, we are having more and more containers, mostly with Flatpak in that case, and it just makes everything much worse. For example, if you have a hot plug event, then the hot plug event doesn't make it into the container, for example, because netlink just doesn't work properly if you use user namespaces. hot plug just doesn't work because of that. And for containers, we also need to bind mount like the devices, like the FDRI devices, and to the container for them to be useful in there. But that's also a decision we make up front. Like we decide, okay, those devices get mounted in there, those don't get mounted in there, and then we have made a decision, and like everything is fixed, and there's nothing to do anymore. And then the whole problem of configuring stuff, like if you use something like DRI prime, the way it works is that an environment variable is being set, and then you just hope that a client picks it up. But if you have a container in the middle, it might not pick it up because like the environment might not make it to the container. So yeah, it just makes everything more brittle, and it doesn't always work like it should. So in general, we would also in containers like to avoid having to mount random devices from dev, and that's also like not really possible with the current situation.
The next thing is what I call client-side offloading. That basically adds insult to injury, because right now we have a Windows system mandated primary GPU, and the client needs to make sure that whatever it's doing works on that GPU, right? So we end up in a situation where the client then also needs to create a copy of what it just rendered for the primary GPU. And then the compositor might even render that buffer on an output connected to the secondary GPU the client used in the first place. So we now have two copies where we kinda didn't even need one. So that the client is doing the offloading at all then also adds unnecessary buffer copies and potentially migrations of the buffer into system memory so multiple GPUs can access it and whatever. That all kills performance and then gets to the reputation that all of this is slow, right? I'm arguing compositors should do this differently, and also that they should benchmark stuff and copies and stuff, which then brings us also to the next issue. GPUs are continuously running on a lot of these laptops and are active and don't go to sleep. This is also sometimes about compositors not doing resource management very well. For example, keeping context and other GPUs resources allocated, which then prevent the device from going to sleep. But this is also an issue in clients, right? You have clients that might open that GPU, don't really clean it up, even if they don't end up even using it. And suddenly you have a giant power draw and not a really good way to see and visualize why and how something is going on there.
Yeah, that brings us to the next point, and that's kind of that there isn't really a good way to see what's going on in the system. There might be a lot of applications which are using one GPU or the other one, and in general you don't really know which one it is. So it would be nice if there was like some way to actually see which GPU is currently currently active or keeping something active. Yeah. And then the next point, it's also kind of like very limited currently what we can do, in the sense that you can only, with current solutions, you can basically only say, okay, use the default GPU or just use the dedicated one. But then if you have a third GPU in there, like, what is it? Like, which one is it? You don't know. So it's all kind of not very configurable or not very explicit in it.
Okay, so this is not a new problem. Let's talk a bit about what previous attempts already kind of solve, or attempt to solve at least.
Right, so one of the more popular ones, I guess, is switcheroo control. And it's at the very, at the core of it, it's a very small service which like tells you which GPUs are there and which is like the default GPU. And then you can, well, whenever you have an application launcher, basically, you would query the thing, and then it would tell you, okay, please use this environment variables and pass it along. And then you hope that the client actually picks it up correctly and then uses whatever you wanted it to use. Yeah, so the problem kind of is that every kind of launcher has to implement it themselves. Like, for example, GNOME Shell implements this, but like there are other compositors who don't. If you started from a terminal, for example, there's nothing that could set the thing, so it just won't work there.
So next is an ongoing attempt to get some configuration from Kyle Brenneman. I hope I said that name correctly. into various parts of the ecosystem, mostly libglnd, but also Vulkan Loader and other Mesa components to add like some static configuration where you could say, okay, I'm having profiles of like power saving mode and of like maybe what I consider to be the dedicated GPU, where you could also then have a way, if you have free GPUs, to assign these different profiles to your GPUs and have actual configuration of what the application should use what. I've only slight problems with this approach, except for it's not merged, so nobody really can use this. And that is mostly static configuration, right? It's a little bit annoying if you want to maybe dynamically change this at runtime, because you, for example, are switching to battery mode and you want to discourage anything from using the dedicated GPU now. That could obviously also be encoded in static configuration, but you might have other cases where the user dynamically wants something to happen without like a clear indication like, oh yeah, I'm on battery now. Yeah, and the last one is Linux DMA-BUF Wayland protocol and the proposed version 6, which would then finally allow the compositor to advertise not a main device, but a set of devices that it can sample from, which would eliminate the copies I talked previously about by basically moving the client-side offloading code into the compositor, which can then skip that code if it ends up in a case where it's doing compositing on the secondary GPU anyway, and there's absolutely no need for any new copies. Okay, so from the problems that we had in the beginning, what is also kind of addressed from the current state of things, client-side GPU selection, yeah, there is switcher control, there's stuff we've talked about why we don't think this is very good. The container thing is kind of not really addressed. We are doing a bunch of hacks of what devices to mount, what environment variables to pass. We have proprietary drivers that use different environment variables. All of this has to be encoded in the sandbox. We have client-side offloading being worked on, but not being addressed at all at the moment. And then nobody actually attempts to do anything about GPUs continuously being active, and in that context, transparency and visualizing the current state to the user. So we hope to do some name bike shedding on this. Please, anybody who has great ideas, find us in the hallway. We are proposing a new daemon to fix the solution, because what has not been solved by having just another daemon on your system.
All right, so what is this daemon going to do? Well, first of all,
put all the things up for you.
Yeah. Well, I mean, so first of all, what we wanted to be is a small warning service, which means that, well, Warlink is a new IPC protocol, and it's basically just passing a bit of JSON over a Unix socket, and that's all there is to it. So it's nothing complicated, really. The nice part about like being just a Unix socket is that you can just access it, like if it's on the file system, you just access it, but it also works pretty well with containers, because you can just bind mount it into the thing and it will work. And you can even stack it, like if you have a container in your container, you can bind mount another thing in the next container and it will just work. So that's kind of solving the container problem, I guess. And what we wanted to do is basically provide what, like a kind of dynamic and virtualized view of the GPUs in the system, and also access to the GPUs, which means that we just want to have maybe a kind of, we want that Mesa accesses the GPU over this kind of service, and it might see not all of the GPUs in the system, but it might also see all of the GPUs in the system, and we wanted to open basically the device over this service instead of going through DevDRI. We also want the service to provide basically the configuration for the GPU, which means that, well, first of all, we want to provide this kind of configuration that usually just exists somewhere on the host in files. So just think about like the quirks that you might want to apply, or whatever else of configuration that you can have. By sending it over the service, it means that you don't have to care about the files on the file system anymore. It's just all coming from this one socket. We also want to provide the preferences in the GPU, so and do so dynamically, which means that the list of preferences should be coming from there, but also whenever the user does something or the system does something, for example, go to a power saving mode, it should maybe change the list of the preferences of the GPUs. And yeah, what also should happen is that the configuration is kind of dynamic. So whenever something changes in the system, the daemon should have the ability to react to that and change kind of what the applications will see. So like the example with power save is one, but also GPU hot plug. So imagine a GPU goes away, so you want to have the configuration in there about what happens, which devices will be shown, and what's the preference. But also kind of configuration from the user, so that the user can at any point in time decide, okay, go into some kind of UI and change something about like a specific application. So for example, I want this specific application to always use this GPU. And at the end of the day, we also want to make it possible to see what's going on in the system. So because every access to the GPUs will go through the service, it means that we also have like a global view of what's going on in the system, which applications are using which GPUs, and it means that you can easily see, okay, this application is keeping the GPU active.
Okay, so I'm rushing through this because you did like half of this on the previous slide anyway. So the endpoints would be very limited. The filtering for GPUs and potentially reordering would, in our opinion, be best suited to be in the loaders, so libglvnd or Vulkan loader, so that it works across drivers and ICDs and we don't have to worry about anything there. Mesa and also proprietary drivers would need changes to change how they open devices, right? Because which nodes exactly they're opening and what file descriptors they need depends on what the driver actually does in the background that is not abstracted on the graphic API layer. And then desktop environments or other integrators, CLI tools, whatever, that care about the state and maybe want to visualize that information can get device-specific configuration, visualizing the info about the current state for visualization purposes or configuration or other stuff. And the good thing is we can do all of this in steps, right? We even already just having a filter option for GPUs would be tremendously helpful and is an API that is completely orthogonal to the question of can we visualize this and do we have a query API for that? And the sandboxing problem is also another one that we can solve later or first or in whatever order we kind of want.
Right.
We kind of don't have the time for this, but maybe...
Yeah. No, okay, just one sentence to this. Like, there's always a question of, like, when you create a service or something, like, what IPC mechanism do you use? We want to use warlink just because it's really simple, because it's just a bit of JSON over a Unix socket. But so it's kind of much nicer than dbus in that sense, and it doesn't have, like, this whole complex daemon structure in it, and compared to files, we get the ability to have like events. So if you have just a file, then nothing will ever change. So that's basically the rationale here.
Yeah, we would have loved to have a demo at this point. There is code, nothing that compiles, unfortunately, but we got both sick in the last couple of weeks. So I'll leave you with this super nice screenshot from our Figma tool. This actually exists on Cosmic. We tried to visualize the current state, but the hacks and how we get the information about what application is running on which GPU is absolutely horrible. I would love to get away with all of this. So this is like a proper daemon to hopefully have an interface somewhat like this on Cosmic, probably something simpler on other desktop environments, but really anything should be possible. This leaves the last very big issue, which is X-Wayland. Obviously, none of this works with X-Wayland. Unfortunately, somebody started this discussion already years ago. Austin, if you're around, please, we would love to talk with you about this approach because we would love to fix that as well. So looking back at our problems, the only thing that's kind of not addressed by these changes is the GPUs being kept active. I don't think that is a problem that will then continue to exist and will go away with better transparency because the user can see what apps are behaving badly or what drivers and report this to the correct sources, because right now this information is deeply buried in SFS and nobody does that. Okay, so we still need help on all of these efforts. If you find yourself here, please reach out to us. We are on the hallway track. We want to hear from your requirements. The current API service is really simple. We would love to show you and talk to you about it and get some feedback whether you think this is a good idea and how to integrate it. And yeah, exactly that. We would love to have time for Q&A, but I think we're already 30 seconds over. So thanks everybody for listening.
Thank you.
Thanks a lot.